Hello, and welcome to Calculus Lesson 44. All I can say today is it must have been a good day for golf. John Saxon, the author of this textbook, man, he went long today. But hopefully I'll get you out of here pretty quick. So here's the idea. We are now going to talk about the chain rule. And this is a thing that students will forget constantly, okay? For whatever reason, I'm always like, chain rule, chain rule, chain rule. Anytime you have a function inside of a function, and you take the derivative, you will use the chain rule. Now, here's the official definition of the chain rule. Suppose you are taking the derivative of some function f that has some function g inside. G is inside of f, okay? When you see it, you'll know it. We've already been doing some of those practice problems where you have to find g and find f. This is why. So the chain rule says this. Take the derivative of the outside function and leave the inside unchanged. So just leave that there for x. Then multiply by the derivative of the inside function. Okay? That is the chain rule. Now let's see it put into practice. Suppose you have, well, I'll just use one of their examples. 2ln of u squared. Now, here obviously you could use ln tricks to pull out the 2, but let's use the chain rule. So the outside function would be ln, in fact 2ln. The inside function, because it's inside the parentheses, it's inside the other one, u squared. So how do I do this? Well, I'm going to take the derivative of the outside. 2ln would be, if I just had 2ln of x, it would be 2 over x. But now I have u squared in there. So I'm going to plug in the entire inside function unchanged to my derivative. But that's the easy part. That's like, okay, cool. You could have done that without me telling you anything. But in order to complete the derivative, you must multiply by the derivative of the inside. So this is actually 4u over u squared, which is 4 over u. So derivative of the outside with the unchanged inside that function times the derivative of the inside. Let's do another one. So we have sine of 1 over root x. Okay? Derivative of the outside is derivative of sine, which is cosine. I leave the inside unchanged. Then I multiply by the derivative of the inside. Remember 1 over root x is the same as x to the negative 1/2. So when I take the derivative of that, I'm going to get negative 1/2 x to the negative 3/2. And that's your derivative. Here's my eraser. It's not horrible. It actually is a lot easier than you having to go through all the trouble of u substitution, making this u, then you get the same answer. Okay? So use the chain rule, just remember that, and it will speed up your derivative taking process. Now, the rest of this lesson is that we are adding 2 more definitions of the derivative. They're both quite useful. I'll give them to you first, and then I'll draw the pictures so you can kind of see where they're coming from. So the first one is called the alternate definition of the derivative in the book. Obviously, it's still going to have a limit. What? That's what I wanted. I knew it was a. F of x minus f of a over x minus a. So instead of the limit as x approaches h, and then you adding some delta x, here's your picture. You have your function, it's doing crazy things. You have the x where you want the derivative. And then you have some point a. And you take the slope here, but you're moving a closer. It's basically the same thing as the x plus delta x1, except you're making it a little bit easier on yourself. So that's another definition of the derivative that you need to know. When you see that, you should go, oh, they're taking the derivative. Next one is the symmetric derivative. So this one's a little tricky because you take your function, and if you want the value at x, you actually take the derivative at x plus h, or the slope from x plus h and x minus h, and then take the limit as h approaches 0. Kind of funky, but works out. So this one is f prime of x is the limit as h approaches 0. So you want these points to get closer and closer of f of x plus h minus f of x minus h over 2h. Again, you're just taking the slope between these 2 points. So y2 minus y1 over x2 minus x1. And that, my friends, is problem set 44.